In December 2023, an engineer at an Intel facility in Arizona lifted up a small, transparent square of glass with a chip mounted on top. It was the payoff of more than a decade of research. 10 years, a decade of quiet, patient work on a material almost nobody outside the industry was paying attention to. Intel had every reason to be proud. They'd cracked something genuinely difficult, something Samsung, TSMC, and the rest of the semiconductor world had been circling for years without solving. Then, at CES 2026, Intel made it official, the first commercial processor in history built on a glass foundation shipped to real customers. A 10-year head start had finally become a finished product. The glass age of computing, as one analyst called it, had officially begun, and Intel was standing right at the front of the line. There was just one problem. While Intel spent a decade perfecting glass chips in the lab, a Chinese company that had never produced a single semiconductor was quietly building the exact factories needed to mass produce them, and it was doing it in a fraction of the time, not 10 years, 10 months. This is the story of how the company that invented the future of chips may have just handed the lead to someone else. And the reason has almost nothing to do with chips at all. Let's get into it. To understand what just happened, you need to understand why glass chips matter and why Intel's decade of work was such a big deal. If you've caught my earlier videos on this, you already know the short version. The most powerful AI chips today aren't single chips at all. They're clusters of smaller chips called chiplets, mounted together on a shared foundation called a substrate. For the last 20 years, that foundation has been built from an organic material, essentially a very advanced plastic. That plastic foundation has hit a wall. Literally, the industry calls it the war page wall. As AI chips grow bigger and hotter, the plastic beneath them expands and contracts unevenly, warping just enough to snap the microscopic connections holding everything together. The plastic that carried the industry for 2 decades simply can't keep up with the size and heat of modern AI hardware. Glass solves this. It barely expands under heat. It stays flat. It supports far more connections and cleaner signals than plastic ever managed. To its credit, Intel saw this coming earlier than almost anyone. They began working on glass substrates more than 10 years ago, back when AI chips were nowhere near the monsters they are today. They bet correctly on a problem that hadn't fully materialized yet. And here's where the industry's shared assumption comes in. Everyone believed that whoever cracked the science of glass first would win. Intel solved the science. Intel shipped first. So Intel should win, right? That assumption turned out to be wrong. Solving the science and winning the race are two completely different things, and the gap between them is exactly where China walked in. Let me show you just how hard the thing Intel pulled off actually was, because it makes what happened next even more surprising. Building a glass substrate is brutal. I've covered the manufacturing nightmare in detail in earlier videos, but here's the gist. You have to drill thousands of microscopic holes, each thinner than a human hair, straight through a sheet of glass thinner than a fingernail, without cracking it. Then you fill those holes with metal that expands at a different rate than the glass around it, without the two pulling apart under heat. Then you have to keep the entire surface flat to within a fraction of a hair's width across the whole panel. Glass is rigid, brittle, and unforgiving. It punishes the smallest mistake with invisible cracks that don't surface until months later, when the finished chip suddenly fails. For years, the share of glass substrates that survived manufacturing defect-free was so low that producing them commercially made no financial sense at all. That's what took Intel 10 years, not because Intel was slow, but because the problem was genuinely that hard. They had to invent the processes, the tools, the inspection methods, the entire approach, largely from scratch. By the time they shipped Clearwater Forest in early 2026, they'd earned every bit of their first-mover advantage. Intel's launch marked the world's first successful high-volume implementation of glass core substrates in a commercial CPU, the beginning of what engineers were calling the glass age of computing. So how does a company with zero semiconductor history show up and threaten that 10-year lead in a matter of months? The answer is the most surprising part of this whole story, a twist almost nobody outside the industry understands. The hardest part of making glass substrates isn't the chip science, it's the glass handling. Cutting enormous sheets of ultra-thin glass with perfect precision, keeping them flat, inspecting them for microscopic flaws, moving them through a factory without shattering them, and doing all of it at massive scale every single day, with yields high enough to turn a profit. Now ask yourself, What other industry on Earth has spent the last 20 years mastering exactly that? Precision handling of giant, ultra-thin, flawless sheets of glass at enormous scale? Display manufacturing. The screens in your TV, your monitor, your phone. And the largest display glass manufacturer on the planet is a Chinese company called BOE. BOE has never made a semiconductor, but it's spent 2 decades perfecting the single hardest physical skill that glass substrates demand, handling big, thin, flawless glass without breaking it, at industrial scale profitably. The factories already exist. The expertise is already there. The equipment is already running. China's ability to repurpose existing LCD and OLED production lines for semiconductor-grade glass has handed it a startling speed advantage over global giants like Intel and Samsung, who've been researching glass substrates for years. Think about what that means. Intel had to learn glass starting from a chip maker's point of view. BOE is approaching it from a glass maker's point of view, and it turns out glass handling was always the hard part. Intel spent 10 years learning to handle a material China had already mastered for a completely different purpose. That's the 10 years versus 10 months gap. It's not that China is smarter or working harder, it's that China was already standing at the finish line of the hardest part of this race, holding skills it built for television screens, while everyone else was still learning how to run. This isn't theory, it's happening right now, and the pace is genuinely startling. By January 2026, BOE had already moved from small pilot lines to full-scale panel production, leaning on its ultra-thin glass expertise to produce substrates with ultra-low warpage. Its mass production timeline is one the rest of the industry simply isn't matching. And it isn't just BOE, the entire Chinese supply chain is mobilizing at once. Visionox, one of China's leading display makers, is pouring 5 billion RMB into a project that speeds up its own glass substrate work. On the equipment side, Chinese manufacturers like Hans Laser have started shipping domestically built laser drilling equipment for the through glass via process, tackling one of the key bottlenecks in glass substrate manufacturing. And packaging firms, including Tongfu Microelectronics, have already built out through glass via packaging capability, with product-level applications expected between 2026 and 2027. Here's the strategic detail that matters most. According to industry sources, Chinese suppliers are deliberately trying to stand up entire manufacturing flows all at once to shrink time to market rather than scaling incrementally the way the rest of the industry typically does. That's the difference in philosophy, in one sentence. Intel built glass chips the careful way, one validated step at a time, over 10 years. China is building the whole chain in parallel, all at once, racing straight for volume. One approach is methodical, the other is explosive. And in a market where being first to high volume is everything, explosive tends to win. Here's the part that should make Intel nervous, a lesson that keeps showing up throughout the chip industry. Inventing a technology first doesn't mean you win the market. What wins the market is reaching high-volume production first, then accumulating the manufacturing know-how that only comes from pushing millions of real units through real factories. Every substrate that runs through a production line teaches the factory something. Every defect solved becomes knowledge that can't be bought or copied. Whoever reaches true mass production first starts climbing that learning curve first, and the customers who design their chips around that supplier's specs don't switch easily because requalifying a new supplier costs years and real risk. This is exactly the dynamic that made TSMC nearly untouchable. TSMC didn't win because its technology was permanently better than everyone else's. It won because it reached massive volume first, learned faster than rivals could catch up, and locked in customers whose own roadmaps became dependent on it. Intel, ironically, has spent years on the painful side of that exact lesson, technologically capable, but behind on volume manufacturing. Now, the same pattern may be repeating, except this time Intel holds the early invention while someone else races toward the volume. Intel invented the glass chip, but if BOE reaches reliable mass production first, riding its 2-decade head start in glass handling, then the manufacturing knowledge, the customer relationships, and the cost advantages could all stack up on China's side of the board, and once those advantages compound, they become extraordinarily hard to reverse. Being first to invent gets you a headline. Being first to volume gets you the industry. Now let me be straight with you because I don't want to overstate this and have you call me out in the comments. China has not won the glass chip race. Not even close. Intel genuinely shipped first, and that real commercial first-mover advantage matters enormously. Intel currently holds the lead, and Samsung is targeting mass production in the second half of 2026, with a pilot line already turning out samples. This is a four-way race between Intel, Samsung, TSMC, and China's manufacturers, not a finished story. There's also a real catch on China's side. Glass is famously fragile. Industry analysts warn that the mass production timelines being floated across the board are probably too optimistic, precisely because glass substrates are so delicate. Microscopic impacts during cleanroom transport can shatter an entire panel, and the adhesion issues between smooth glass and metal routing aren't fully solved yet. Some analysts think large-scale commercial adoption won't really arrive until 2028 for anyone, China included. So the honest framing isn't China crushed Intel. It's something more interesting. Intel spent a decade earning a lead that China's display industry may be able to erase in a fraction of the time, not because China out-invented anyone, but because the hardest part of this particular race happened to be a skill China had already mastered, for televisions. That's a genuinely different kind of competition than the chip world is used to, and it's why this race is suddenly wide open when everyone assumed Intel had it locked up. Here's my honest opinion. What fascinates me about this story is how completely it upends the way we usually think about technology leadership. We assume the company that invents something first and works on it longest deserves to win, and usually we assume it will. Intel did everything right. They saw the future early. They invested for a decade. They shipped first. By every traditional measure, they earned the lead. And it still might not be enough, because the decisive advantage in this race didn't come out of the lab. It came from a factory floor in China that was built to make TV screens. The skill that cost Intel 10 painful years was something BOE had been quietly perfecting the whole time for a completely unrelated product. Sometimes the most important advantage in a technology race isn't the technology at all. It's the boring industrial capability sitting in some adjacent industry that nobody thought to connect. I think the next 2 years of this race are going to surprise a lot of people who assumed the inventor automatically wins. The lead Intel built is real. It is absolutely not safe. Here's my question for you, and I want your honest take. Does the company that invents a technology deserve to win the market? Or is it fair game for whoever can manufacture it best, even if they show up years later with skills borrowed from a totally different industry? Is that brilliant strategy, or is it unfair? Drop your real opinion in the comments. I read them all, and this one's going to divide people. If you want to keep following this race and all the others where the expected winner suddenly isn't, subscribe to Eastern Engine and turn on notifications. Glass, diamond, silicon, the entire foundation of modern computing is being rebuilt right now, and the story is moving faster than almost anyone realizes. Thanks for watching. I'll see you in the next one.